Hi everyone, welcome to Mastercam, the complete course. I hope you are fine. So we have already started the module number 4, which is all about the chaining and toolpath parameters. And we have discussed the chaining basic and chaining options. We have these things are discussed in the previous videos also. And just discuss about how the toolpath workflow works. And we have discussed a little about the toolpath type and tools and orders and general cutting parameters for certain toolpaths and linking parameters. So in the previous video, we have discussed the toolpath workflow. As you know that the first thing is to import the model or create a model, then define the machine, then define the toolpath technique, simulation and verification, generate G code, and in the last way to load the NC program into machine. So now let's get study more about the toolpaths. So here what you see on my screen is a 3D model. I just made it for examples. And what we're going to do is we're going to apply 3D strategies or 3D toolpaths on this 3D model. So let's get to it. So first thing first, we have to set our origin. So let me define this plane. Go to top plane and double click on it, or you can create another plane. Okay, so just go and drag plane some about here. Okay, so let me define this plane x 0.0, y 0.0, and the 60 millimeter. Okay, that's it. So I just named this plane to plane number 1. Okay. So now I'm just have to select my plane. You can just go and click here, geometric plane, work and construction plane. So this is what I have my plane to set. Now, what we're going to do is we're going to study the 3D toolpaths. So for this part, which I'm being using here is the milling part. So what I'm going to do is I'm going to select my mill machine here by default. Yes. And now what I'm going to do is I'm going to apply some 3D toolpaths here. So in the previous video, we have used the optimize rough toolpath, and this time we're going to apply some pocket, project, parallel, and some area rough. So this area rough is also included in this. Okay. So what we're going to do is we're going to apply the pocket, project, and parallel toolpaths. So let's do and start the pocket. So what you see on my model, we have a circular cutout here, and we have a inclined surface here, and here we have a pocket. This is a rectangular pocket here. So what I'm going to do is I'm going to select this surface. So I want to machine that surface, and for that purpose I need this surface to be selected. So click OK or end selection. So my dry surface is this, which I want to machine, and my containment, or we can say that my boundary is this. So I just select, go and hover on the edge of this pocket. So it will automatically select, click, and it will automatically select this pocket. Okay. Click OK. So now here we have the rough surface pocket parameters here, and what you need is you need to select an appropriate tool for this pocket. So let me go and select some end mill here and click here. Go and select the define tool. I'm going to select an end mill 8 mm and double click here. Just give an overview. The diameter is 8 millimeter, overall length is 75 millimeter, and the cutting length is, let me say that it's a 40 millimeter cutting length. Okay. And we go to next. It's a flat end mill. Tool number is 1. And finish. Let me define spindle speed 13,000 RPM. It's just giving you roughing idea about the spindle speed. Make it 2,000 millimeters to feet. And how about the coolant? Yes, we need coolant also. Okay. Go to surface parameter, and here is the surface clearance angle, which is 50 millimeter above. So, okay, we needed surface clearance, but after the retract point, which is 25 millimeter in absolute. And how about the feed plane? Let me define that the feed plane should be 5 millimeter above the plane. Okay. So how about the tool containment? So we have selected tool containment or the tool boundary, which is at the center or outside. So let me define it, make it inside, because we want to cut or machine that area inside of this pocket. So I have selected the inside, go to roughing parameters and define the tolerance. So the tolerance by default is 0.025. It's enough tolerance. And if you want to make it more close, just go and write 0.0 or 0.01 millimeter, very close tolerance here. And here what we have, the maximum step down is 2.0 millimeter. Let me define that step down is 0.5 millimeter. Now go and define the depth of cut, because we just have selected the surface and we didn't define what should be the depth of this pocket. Okay, so what I'm going to do is I'm going to select and define the depth of this pocket. So just go, and here it is showing that the minimum is 60 millimeter and maximum is 40. This doesn't mean, just go and select the depth. Click here, yes, and minimum, selecting a point at minimum depth is this and maximum depth is this. Okay. And critical depth. Select the critical depth point, any point. So this shows that it's minus 60 millimeter and then it's minus 90 millimeter. Yes, what you see over this, that this point is 0 millimeter. You see my mouse point, this point is 0 millimeter and 0 to down at minus 60, and then 60 to this point is minus 90 millimeter. That's good and defined. Okay, so click OK and go to gap setting, and the motion and gap, keep the tool down position should be broken or make it smooth. So just want to make it smooth. And how about the optimization? So I want my cut to be optimized. So just go and define these simple clicks to check your parameters turn. Okay. And click OK. And this is going to be calculate, and here you see the pocket. So this is how the pocket operation is being done. Okay. So go to parameters and let me show you the roughing parameters, pocket parameters. We have the zigzag position, we have the constant overloop, overlap, parallel spiral, and parallel spiral, clean the corners, and the high speed and true spiral. All these techniques we have. So you have to select an appropriate technique to get this operation done. Okay. So just go and select the parallel spiral or make it high speed spiral. You can select anything. Okay. So we have selected this. So this is how we can perform the pocket operation. It's very simple. Now let's move towards another operation. You can just go and right click on the toolpath manager area. Just right click and you'll get the toolpaths, milling toolpaths. So all these are the 2D toolpaths which we have done in the previous videos, and these are the 3D toolpaths. Okay, so we have some multi-axis which we will done in upcoming videos. So we have to perform this surface rough cutting operation. So we have done the pocket milling operation. Now let's do the parallel area. Okay, so we didn't define anything here. So it shows that select the boss or cavity. So we didn't have defined anything here. So let's go click OK and now define that area. So I just want to machine that area. I just want to machine that area. Okay. Or if you want to machine that area or that area, you need to select that area. Okay. So what I'm going to do is I've just selected this area, and that area. Okay. I would just want to machine that. Now, these are the drive surfaces, and what I want is I just want to select the containment area, which should be my boundary. So this edge should be my containment. You can just have to select any boundary which you want. Okay. So within that boundary, the operation will be done. Click OK. OK. And we're going to use to 8mm end mill, make the spindle up in 6000 feet is 1500 millimeters. Get the coolant on. Click OK. Go to surface parameter. So we have defined the absolute, which is 25mm. Make it to 60mm. Okay. And how about the absolute position? So make it 25mm again. Absolute position is 5mm and make compensation inside. Okay, we have selected the containment boundary here. So we want to machine all operations inside that area. And how about the parallel rough area? So the cutting method is two-way or zigzag, or one-way or two-way. We can also say that it's zigzag, or just select the zigzag. And how about the maximum step down is 2mm. Okay, and the maximum step over. So we have the 8mm end mill, and for that we need to have a 50% of the cutter to be utilized. So it's 12mm, it's so far away. So let's make it 4mm. Okay. And how about the cutting depths? So just select the cutting depth. So we just want to assure that we want to machine from top area to this area. So just go and select the top area, this point, and select the maximum point at that here. Okay, so 0 to 60mm, I just want to machine that area. Click OK. And go to gap setting, just make it smooth, optimize your cut order, same as in the previous, and go to advanced. So all these things are okay. Click OK and OK. So what is going to do is going to machine all that area using the parallel. So what you see over here is the cutting path is in the form of lines. It's all parallel to each tool path. Okay, so this is what you see, all parallel to each. So you can change your cutting angle, by the way. By go to parameters, you see that the angle is 0 degree. So what we're going to do is I'm going to make it at an angle of 90 degrees. So the tool path will be vertical position. Okay, here. So this shows that the cutting will work like this. So you have to select an appropriate method of cutting. Okay, so this will also indicate how much material will be left over. So what I'm going to do is I'm just going to select this and hide this. You can go and hide your operation here. So this operation is hide. I'm going to select this and hide. So next, load and go and move towards another operation, which is all about the radial position. So what you do is the cutting operation which is being done on this will be in a clock direction, just like the seconds and minutes are in a radial position, in a circular position. So what I'm going to do is I'm going to machine that area. Just go and select that area. And how about the containment? Yes, just want to select this edge as a containment. Okay. All the way we are going to use this and make it little bit 1500 millimeters. Surface parameter, make it absolute, make compensation inside. And how about the radial surface? Make it the radial surface a maximum depth of 2 millimeter and make it from inside to outside. So cutter will be work inside to outside, not from the outside to inside. Okay. And make it plunges. Okay, so we just make the offset distance of 1 millimeter. So we using the 8 millimeter end mill, and only 1 millimeter will be from this center point, which we will have to define later. So what will be the depth of cuts? Definitely from 0 to minus 60 millimeter. Okay, and gap should be smooth. Make the customer cutter cut optimize. And okay, so here we have to define the radial position. So it will work from the center point. So let's define this center point. So we have defined the center point, and see here the cutter will be work in a radial position, just like the clock works. Okay, so it will be at a 1 degree cut. To take every 1 degree cut and take an offset of 1 millimeter and cut whole thing. Okay, so it will not remove any material inside that area. Okay, so that's the thing. So this is how our radial surface, rough surface works. So now let's move towards another operation. Go to milling toolpaths, go to surface and the project. So project means that just it works simply like a projector. Okay, we have a surface here. So I just want to say that we have this surface. Let's first discuss. First make some projects curves here. So let me go to top plane. I'm going to select the top plane construction, and what I'm going to do is I'm just go and make some curves. Okay, make it some spirals. So I just make a radius I just make a spiral way. Okay, so what you see in this, that this is 2D curves. Okay, so this all these are 2D curves. What I want is I want all these 2D curves to be projected on this surface, and all my toolpath will be work like this. So it actually gives you an ultimate factor that you can do as you want. The toolpath will work according to your desired work frame. So here what you see is this is 2D geometry, and what I'm going to do is I have projected this tool on this surface. Let me show you. So let me delete this first. Yes, and again go to Wing Toolpaths and project. Okay, so I just want to machine that area using that curves. Okay, so this should be my surface area. Okay, and here are my curves. So all these are my curves. So all these are my curves. And what is going to be done? All these curves will be projected to this surface. So the surface parameter will be same. Let me define that this should be the feed rate to make me 1500 millimeter, and the surface parameter is same, absolute. And there is no tool containment because you have to follow the 2D wireframe. And the project curves. So here you see that we have the three options here. The project type should be NCI, curves, or points. So what you see over here, if you have NCI, you have to select your previous operation, and the previous operation will be projected towards this surface. So what I am going to do is I'm going to select curves here. We have defined ourselves the curves, and we have selected the curves. Make the step down 1 millimeter, and the depth is absolute. Let me define that minus 60 millimeter from this point to this point. Gap setting is smooth and optimized. Okay. Click OK. So what you're going to see is the cutter will be what you see here, the curves will be projected on this surface. Let me show you. So this is how the cutter will work, like this. You see, this is how the cutter will work on this surface. The cutter tool will follow your project curves and will machine that area. So this is how the project curves will be work. So if the project curves will be high above on that surface, it will definitely project towards this surface and cut down the material. Okay. So we have done this, and now let's move towards another option, which is the next thing, which is surface flow line. So this is another method to machine that option. Let me define the surface which I want to machine. I just want to machine that surface, which is a clear way to understand. Click OK, and just select the flow line. So in the flow lines, you have to define the flow of cutting tool path in certain directions. Just like here, what you see over is the direction is from downward to upward direction. So you can just define by flip the offset up and down. So here is the up direction, and here is the downward direction in the downward direction. So just don't want to move direction downward, just want to move it upward direction. So what about the cut direction? Just click and you see that the direction is from top to bottom or in a sideways. Okay. So I just want to machine the tool in just like this way. Okay. Get this. Now about the step direction is from the upward up to down or down to ward. So this is from down to upward direction. But in a roughing operation, you have to done this by from top to bottom side, not from the bottom to top side. So it should be start from the top to bottom side, or start from the far away direction or the near direction. So this is how we can do the flow line data. This is flow line data. And click OK. Now you have to define certain things here. So as usual, we have the spindle RPM and spindle RPM. We have the feed rate. We have the coolant on direction. Surface parameter, we have the absolute and the absolute direction. Flow line rate. So we have these maximum step down of 2 millimeter and the step over direction. Let me define the scale loop height, see, which is all above 1.25. Mean to say that it will just follow the surface accordingly and make it 1.25 millimeter high step. Just give you an idea. And the depth should be from 0 to minus 60 minutes. Okay. So tool plane is plane and this plane. Okay. So this is how it is working here. Okay. This is how it turns. Let me make this. Let me show you. It will just follow the surface and make it machine done. And how about the distance? If you define and fix the distance, it will just follow the 2 millimeter step over distance, just like others way did. So it shows it will be constant 2 millimeters distance from the surface and make the machine and make this surface machined. And so this is what we have the top, and this is what we have the maximum depth. Okay. And this is how we can perform the maximum roughing operation. The roughing operation will be done like this. The finishing operation will be done in the previous in the previous tool. Okay. So this is how we can perform the roughing operation by 2 millimeter step over. Okay. So let me show you how it will work like that. This is how it works. And move the material from this side. This is 2 millimeter step over. Okay. So each tool path is 2 millimeter forward. Good. So this is how we can perform the surface rough flow line operation. So I'm just going to hide this area and let me go and go to surface rough, and we have the pocket and we have the contour. So let's go and select the contour option. So contour option is it's little bit talk about the outer profile operations. So if you want to do the operations inside operations like this, we have the cavity here and we just want to remove that material. We have a hole and we just want to contour that surface area, or we want to just move the cutter peripherally to this surface or tangentially to the surface. Then we use this contour area. Let me just select this area and just want to machine that area. Okay. We have already inside, which is being made by using the pocket operation. So click OK, and we have the containment option. So let me select the containment. We have a 3D, this like hole, and okay. So using the spindle speed at same, make it 1500 millimeter. Go and select the OK to surface parameter. Okay, that's okay. Make the compensation inside. Okay, so you would want to operate inside, not from out, not on the outside area. And follow the surface or make it ramp. Optimize cut. Okay. So what you see over here, it just let me first hide this area. Go to Earn, and here we have to display, make it black. Okay. So what you see here, you see a tool will helically be operated outside this operated and make the surface of this hole clean. Let me show you how it works. So just processing the data like clean movement, showing the like this. So this is how it works. So we have already selected the direction of cut. It's 2-way or 3-way. So therefore it's done like this, okay? Or you can either change the parameters, ramp way in a 2-way or 1-way direction, okay? Or we can say that follow the surface, 1-way. Click OK. Just make it 1-way. Go to parameters, make it this. And depth of cut is okay. Go to gap setting. Okay, advanced setting. Okay. So here we have. So this is how we can perform the surface contour operation. You can also perform this surface contour operation on this side or on this side. Okay. So let me tell you how we can do this by go and select the contour and select the surface. I just want to do this. Make sure that you have to contour the surface which is present outside or inside. Okay, you don't do this on this surface. Okay, so most of the time we use the surface contour operation on the outside. Click selection. Here we have to select the containment, and let me select this containment, and here we have to select OK and make it same default setting, make inside a rough or ramp the cut. OK. So how about the absolute position from 0 to select reset, select minimum, and this makes it. Okay. So now cut found, check tool, depth of cut in roll or edges. Okay. With the surface parameter, go to contour. And so it shows that make it inside. Okay, so go to geometry and we have to select the surface. So this surface, this surface, and this surface. Okay. Let's do it. Now cut font, check the tool, depth of cut. And so so this time this surface is not being working, and let's do it again on other side. And what I'm going to do is just select this area. Okay. And this is my drive, and this would be the containment. Go to this and just select this surface. Would be the contain. Okay. And we have all the settings done. Let's go and apply. So this contour operation is applied here. This looks same as like a flow line surface area. Okay. So it will never, it just have to follow the surface. So make sure that in the contour operation, the cutter will remove the material in a very small amount because it all moves the material from the peripheral side, or we can say that it removes the material tangentially to the surface which is being selected or which you want to move, just like this surface. Okay, so the contour operation on this side is always done for the smoothness of surface using the bar nose operation. Okay, so you don't need to use the cutter on this surface for the roughing operation. Just for the finishing operation, you have to select that cutting tool or cutting operation, which is a contour operation. So now let's move towards the other operation, which is always all about the rest mill operation. Okay, so this is the rest mill. So the purpose of rest mill operation is the material which is being not cut by the cutting tool. For example, you have, for example, let me show you that we have did the pocket here. So which is the first operation. And we didn't set any material for other operation. For example, we have set 0.0 millimeter. It means that the cutter will finish or cut all the sizes according to this pocket. Okay, it will never leave any material. For example, if I said that it should leave the material from the drive, let me 1 millimeter from the drive. So what will happen? It will never move the material 1 millimeter from the wall. So let me show you this. So you see this? It will never move that material. So this is what we have, the 1 millimeter from all side. Okay, from the walls and from the floor side. So what I want to is, I want to move that material in a rest operation. So for that operation, we have the rest operation in a roughing operation. Go to surface ref and rest of mill operation. So which surface you want to do? So I just want to move that surface. Okay, click OK. Yes, this is the drive surface. And how about the containment? Yes, we want to contain. We have to apply the boundary. Okay. So all we have is same thing. We have the same parameters. Go to surface parameter, same as absolute. Make the compensation inside. Go to rest min, and here we have the options here. So the maximum step down should be 2.0. Let me say that it should be 0.5 millimeter. And the step over would be 2.0. We have the 4.0 step over because we are using the 8 millimeter end mill. And should be follow the surface and make the cut optimize. Go to rest material, and in the rest material you have to select the operation which left that material. If it left in all operations, it will follow all the operations. But if you have selected only toolpath, let me select one other operation, which is this one. So it will remove the material from this operation only. Okay, click OK and just apply it. So here you see that it moves the material from the no side. Let me go and hide this. So what you see over here is it moves the material from this side, 1 millimeter. Okay, or you can set the depth of cuts here. Go and select the depth. So which is already done. Okay. So this is how we can perform the rest operation. So now let's go and select all operations here. So we have all the operations here in the roughing operation. So go to mill, and we don't use the plunge type operation, but the upcoming videos, in the next video, we'll discuss about the plunge operations as well. So the next operations, we have the surface finish operation, which is all same as that of roughing operation, but in the surface operation we mostly use our cutter. With the cutter which is being used is bar nose cutter. For example, let me go and let me hide this all operation and let me make another group, which is total machine groups and machine new tool, and let me define that this is finish tool path. So now what I'm going to do is I'm just apply the finish tool paths. Let me give you an example how it works. So go to finish tool paths and just select anything. That's like I'm going to show you that I want to select a contour, this surface and the containment. Yes, okay. And for this operation just need to select the bar nose cutter. Okay, so go to tool filter and you have to select the bar nose end mill here, not the end mill. Okay, and let me define that I'm just choosing the bar nose of 5mm, and operation for that operation just need a 20,000 RPM and make a feed of 3,000. That's so high, and coolant is on. So all that you have to know that for bar nose operation you have to set your spindle speed at a very high RPM, and feed rate is minimum, but it depends upon the amount of material you want to remove from the surface. So go to surface parameter, make it absolute, compensation inside, and finish both. Let me define the maximum step down. Should be very less. Make it 0.03 or 0.05. Go to follow the surface, make the cut optimize, and depth of cut is all the increment because I just want to finish that area. Go to gap, advanced, okay, make it reset, okay, click OK. And this is how the surface finish operation will be performed. So it will take some time because we have set the step down at in a 0.05mm. So definitely it will take some time to cover all these things. Okay, so just calculating the slices. So it's all about 1,193 slices. And there's optimizing the cut order. And here we have. So what you see is that we have to form the finishing operations. You see that this is very close step over, which is 0.05mm depth, and the step over it will make this surface very fine finish. Okay, so I hope you understand how we perform the finishing operation and how we perform the surface rough operations on a solid body. So we have discussed all the 3D tool paths, and we mostly discussed the roughing operations, and then we have discussed the finishing operation. And just give you an example how to perform contour operation. All these operations are same, but in the finishing operation you have to perform after doing the roughing operation. So you just don't need to perform the finishing operation first. First you have to perform all the roughing operations, and after that you have to perform the finishing operation to make the surface more shine, more look close to your design and close to your sizes, and make the surface more accurate. So I hope you understand. Stay tuned for more videos. Thank you very much.